In the previous class, we were talking about some of the elements of your blockchain. So let me just quickly recall that in this, how these blocks are related to each other that we discussed. So now, how these transactions are related to each other, how these transactions are related to each other, that we slightly want to give the brief about this. So how the transactions and blocks are related to each other means, now that we know that blocks are related to each other based on the previous hash values will be used to create the new blocks, right? So in the application of your blockchain that stores these transactions within these blocks, the transactions within the blocks. So each block has an upper, the suppose if you take the consider the transactions for any gaseous, suppose for any gaseous, then each block has an upper gas limit, and each transaction needs a certain amount of gas to be consumed as part of its execution. So the cumulative gas from all transactions that are not yet written in a ledger cannot surpass the block gas limit. So this ensures that all transactions do not get stored within a single block. As soon as the gas limit is reached, other transactions are removed from the block and mining begins for creating the new blocks. So the transactions are hashed and stored in the block. As we saw in this case, the transactions are the hashed and block in this case. These transaction, let us assume this transaction 1, transaction 2. These are transaction 3 and transaction 4, transaction 5, transaction 6, transaction 7, transaction 8, new transactions suppose. So the transactions are hashed and stored in the block. So the hashes of two transactions are taken and the hashed further to generate another the hash of your next transactions. So this process eventually provides a single hash from all transactions stored within the block. So this hash is known as a transaction Markle root hash. We call that as your transaction Markle root hash, and is stored in a block's header. So a change in any transaction will result in a change in its hash and eventually a change in the root transaction hash. So it will have a cumulative effect because the hash of the block will change and the child block has to change its hash because it stores its parent hash. So this helps in making transactions immutable, and this is you can guarantees that no more modifications. All the transactions will be accommodated in that. So based on this discussion, the application of this blockchain technology is one is your Bitcoin. One is your Bitcoin. So in this Bitcoin, generally how we define this Bitcoin is the first application of your blockchain, first application of your blockchain technology. So the Bitcoin has started a revolution with the introduction of the very first fully decentralized digital currency, and one that has proven to be extremely secure and stable. So this has also sparked a great interest in academic and industrial research. Academic side, the as well as your industrial the research, and introduced many new research areas Since it's introduced in 2008 year, the Bitcoin has gained much popularity and is currently the most successful digital currency in the world with billions of dollars invested in it. So digital currency have always been an active area of research for many decades, as we discussed right from 1980s. So the major concept of this Bitcoin is in 2008 a paper on Bitcoin that is coined a peer-to-peer electronic cash system was written by the author, the Satoshi Nakamoto. The first key idea introduced in the paper was that purely it is a peer to peer network, by the electronic cash network that does need the intermediary bank to transfer payments between these peers. So Bitcoin is built on decades of cryptographic researches. This is built on as we discussed, the cryptographic research. So that we have discussed the cryptographic primitives, such as the research in the Markle tree, which we discussed, that the Markle tree build of, if you have the hashes, the user one, suppose A, B, C, D, some transactions are there. So this every transaction will be hashed, like B will be hashed individually, E will be hashed, D will be hashed, and we said this Markle tree is a binary tree. So then it will form a parent hash of your A and your B, and this parent hash is your hash of your E and your D, which is concatenated, and then this will give the hash of your A, B, your E or D. Okay, we call this as your root, or we call this as your Markle tree. Markle tree. So the hash functions are the public key cryptography and digital signatures. They use the public key. These hash functions are using the public key and your digital signatures. Your digital signatures. So, okay. So, moreover, the ideas such as your bit gold, like your B money, and the hash cash, and the cryptographic timestamping provided the functions for Bitcoin inventions. So all these technologies are cleverly combined in Bitcoin to create the world's first decentralized currency. The key issue that has been addressed in Bitcoin is an elegant solution to the Byzantine general problem, along with a practical solution for the double spending problem in this. So let us see the definitions of your Bitcoin. So Bitcoin can be defined in various ways. It's a protocol, a digital currency. This Bitcoin can be a protocol, a digital currency, and a platform. So it is a combination of your peer-to-peer network, protocol, and some softwares that facilitate the creation and uses of the digital currency named Bitcoin. So note that if the Bitcoin, which starts with a capital B, is used to refer the Bitcoin protocol, whereas a Bitcoin starts with a lower letter that refers to a the Bitcoin in the currency. So decentralization of currency was made possible for the first time with the invention of Bitcoin. So moreover, the double spending problem was solved in an elegant and ingenious way in Bitcoin. So double spending problem arises when a user sends coins to two different users at the same time and they are verified independently as valid transactions. So in this definition, Bitcoin, the first one is your keys and the addresses are used for generating the blocks. So for the key generation purpose for this Bitcoin, as we said for blockchain, for key generation, we use the RSA algorithm to generate the private key and public key. But for this Bitcoin, the elliptic curve cryptography, is used to generate public and private key pairs in Bitcoin networks. So the Bitcoin address is created by taking corresponding public key of a private key and hashing it twice. So first with the it will be hashed twice, and first it will be hashed with the SHA 256 hashing algorithm, secure hash algorithm, which we discussed, and then it will be hashed with the RIP, the ripped MD algorithm, that is 160 in the output size. So the resultant 160-bit hash is then prefixed with a version number and finally encoded with a base 58 check encoding scheme. So the Bitcoin addresses are 26 to 35 characters long. Basically, the addresses are 26 to 35 characters long and begin with the digit 1 or 3. So a typical Bitcoin address generally looks like 1 capital E N G U capital G, like that, the combination of this one, right? So if you see the structure of the block in the Bitcoin, so this is the structure of this is the structure of your block in this Bitcoin. As we said, every blocks like block 1, block 2, your block 3, they are related to each other to generate the Merkle root tree. So in this structure, if you see this structure, here you can find uh, this blockchain, you can find that how many bytes it will use. As we said, for block there will be two fields. One is the header field, another one is the transactional field. So header field requires 80 bytes. So this includes this header field includes the fields from the block header that is described in the we will discuss this in the next structure. But this header field includes the like previous hash value, nonce, timestamp, and the block of hash and the Markle root, and the number of transaction counters in that. This is the variable length, because as the number of transactions increase or decrease, that can be happen. So this field contains the total number of transactions in the block, that including the Coinbase transaction. And then the after number of transactions are identified, then what are those transactions? All the transactions in the block will be defined. So in this, the structure of this block, if you see the block header, as we said, the block header, it requires 80 bytes. In that 80 bytes, the first 4 bytes are used for the version purpose. Which version of the Bitcoin block header is used? So the block version number that indicates the block validation rule to follow, whether it is older one or the newer block, that will be given by the new version. Then it is followed by a 32 bytes of previous block header hash. So this is a double SHA-256 hash of your previous block's header, and which is followed by a Markle root hash, that is 32 bytes for this. So this is a double SH256 hash of the Markle tree of all transactions. The first one, previous hash block, is used to identify give the name of your new block, and Markle tree is used for all the transactions in that block, and which is followed by a 4-bit timestamp. So this field contains the approximate creation time of the block in the Unix epoch time format. So more precisely, this is the time when the miner has started hashing the header of the block. So then it's followed by the difficulty target, and we also call this task as your miner or mining scheme here, the miner. So this is the difficulty target of the block. When you are creating a new block, it must be given a new name. So it is a mathematical function actually. So in this nonce, which is followed by the 4 bytes given for the nonce, means number plus ones. So this is an arbitrary number that miner change repeatedly in order to produce the hash, so that fulfill the difficulty target thresholds. So for more details about this block structure, please go through this link, so that you will get more details and the description about this the block structure header. So let me quickly go through. As we said, the block structure in the Bitcoin, having the block header, having 80 bytes for that, and having the transactions. So what is the structure of this transaction then? So in the transaction field, in this, the transactions are at the core of your Bitcoin ecosystem. So transactions can be as simple as just sending some Bitcoin to a Bitcoin address, or it can be quite complex depending on the requirements. So each transaction is composed of at least one input at least one input and one output. One input and one output. So in this, the input can be thought of as this input can be thought of as coins being spent. The coins being spent that have been created in a previous transaction, and whereas this output as coins being created. So input means coins being spent, and output function means the coins being created. So if a transaction is minting new coins, then there is no input and therefore no signature is needed. If a transaction is to send coins to some other users, a Bitcoin address is used here, then it needs to be signed by the sender with their private key, and a reference is also required to the previous transaction in order to show the origin of the coin. So coins are in fact unspent transaction outputs represented in Satoshi. So transactions are not encrypted and are publicly visible in blockchain. So blocks are made up of transactions, and these can be viewed using any online blockchain explorer. So in this structure, if you see, the transactions at a high level contains the metadata. Then the inputs, outputs. So these transactions are combined to create a block. So this transaction structure, looks like this. It can find in this structure way. So what is there in this metadata means this metadata of your transaction structure. The metadata, this part of the transaction contains some values such as the size of your transaction, the number of inputs and outputs, the hash of the transaction, and lock time field. So every transaction has a prefix specifying the version numbers. So as we said, the inputs means generally each input spends a previous output. So each output is considered as your unspent transaction output. Unspent transaction output. Where this outputs means the outputs have only two fields in the output of this metadata. What are those? They contain instruction for the sending of bitcoins. The first field contains the amount of Satoshi. The amount of Satoshi. Whereas the second field is a locking script. We talk about this locking scripts in coming lecture series. So this locking script that contains the conditions that need to be met in order for the output to be spent. So more information on transaction spending using locking and unlocking scripts and producing outputs is, we will discuss that. And finally, the verification. verification is performed by Bitcoin scripting languages. So in this, it will give you the version number. For that, it uses the 4 bytes. So these 4 bytes are used to specify rules to be used by the miners. What are the rules? That is to be used by the miners and nodes for transaction processing. And next 1 byte to your 9 bytes used for your input counters. How many number of inputs are there in that transaction, included in that transaction to spend the coins. Suppose if I have the 100 bitcoins, so I may spend in different ways. 60 bitcoins spend in one transaction and 20 bitcoins spend in another transaction. So these inputs comes from the output of this. These are unspent, so we call this as unspent transactions. That is output. From there we'll get the inputs there, what we spend in 2 different ways. So how many transactions, how many inputs are there? And which is followed by list of inputs. Input 1, input 2, like that. So each input is composed of several fields that includes the previous hash, previous the transaction out index, and previous the transaction script length, and transaction script, input script, and the optional sequence numbers. So the first transaction in a block we call the coin based. The first transaction in a block we call the coin based transaction, and it specifies 1 or more transaction inputs like this. Then which is followed by the output counter. It takes 1 byte to your 9 bytes in size. So a positive integer representing the number of outputs are there in that block, and which is followed by the list of outputs. What are the various outputs are there, and finally it will have the log time. So this defines the earliest time when a transaction becomes valid. So it is either a Unix timestamp or a block number is used for this. So this is the transactional structure of your Bitcoin. So then we'll see the block header. So in this transactional structure, the most important part is in the block header, as we discussed, in this case is difficulty. Difficulty is most important in block header. That we call the mining. So what is there in this mining in the Bitcoin means mining is the mechanism to generate the hash. For the new block. So the mechanism needs to complicated enough to make the blockchain tamper proof. So in this mining, so this mining is a resource intensive process by which new blocks are added to the blockchain. So blocks contain transactions that are validated via the mining process by mining nodes and are added to the blockchain. So this process is resource intensive in order to ensure that the required resource have been spent by miners in order for a block to be accepted. So new coins are minted by the miners by spending the required computing resources, like doing some computations of like hash functions and these things. So this is also secure the system against frauds and double spending attacks while adding more virtual currency to the Bitcoin ecosystem. So roughly one new block is created or mined in every 10 minutes. in every 10 minutes. So miners are rewarded with new coins if and when they create new blocks and are paid transaction fees in return of including transactions in their blocks. So new blocks are created at an approximate fixed rate. So the rate of creation of new Bitcoin decreased by around 50% uh, uh, in every block size of your 210 of your block sizes blocks. So roughly every 4 years in that. So when Bitcoin was initially introduced, the block reward was 50 Bitcoins. Then in 2012 year, this was reduced to 25 Bitcoin reward. And up to in 2016 July, this was reduced to 12.5 Bitcoin rewards. So the what are the basic tasks of this miner means? What they do, this miners mechanism need to compute these, generate the hashes. So in Bitcoin mining, the hash of new block will be generated based on the previous block hash value, previous block timestamp, nuns, and something more we will discuss about this. So find the nuns such that your HK has a certain predefined complexity, that is number of zeros at the prefix. So the header contains the mining statistics, that is timestamp, nuns, and difficulty for calculating the target. So to understanding these difficulties and bits in more, you please go through this link so that you know what is the mathematical calculation done in the difficulty to compute this difficulty based on target, and how that target is converted into the hexadecimal format, and how those newly computed targets compared with the previous target, so that whether the conditions are fulfilled or not, that will check. So what are the basic tasks of these miners means? Once a node connects to the network, the Bitcoin network, there are several tasks that a Bitcoin miner, the Bitcoin miner performs. That is, one is synchronizing up with the network. So once a new node joins the Bitcoin network, it downloads the blockchain by requesting historical blocks from other nodes. So this is mentioned here in the context of the Bitcoin miner. So this not necessarily a task only for a miner, it is necessary for every node in the network. So then first comes the transaction validation, is the first task of your miner. So this transaction broadcasted on the network are validated by full nodes by verifying and validating signatures and the signatures and the outputs. Output means unspent transaction coins. Second one is your block validation. That is another task should be performed by the miner. Block validation means the miners and full nodes, means all the nodes in the network, can start validating blocks received by them by evaluating them against certain rules. We will discuss what are those rules, we'll discuss. So this includes the verification of each transaction in the block along with verification of none's value. That gives whether the transactions, the block is new block or the old block. If it is new block, then in that block it go and check whether all the transactions are same in the previous block or any new transactions are added in that one. So then after that it create a new block. Creating a new block is another task. So miners propose a new block by combining new transactions with the older one, and the new transactions which are broadcasted on the network after validating them. And after that it goes through the major task is proof of work. So this task is the core of the mining process, and this is where miners find a valid block by solving a computational puzzle. So the block header, in this case, the block header, as we saw, the block header is having difficulties, right? So the block header contains a 32-bit nonce. The 32-bit nonce field, and the miners are required to repeatedly vary the nonce until the resultant hash is your resultant hash is less than the predetermined hash. Predetermined hash. And another task is your fetch reward. So once a node solves the puzzle by doing the proof of work, it immediately broadcasts the results and other nodes verify it and accept the block. So there is a slight chance that the newly minted block will not be accepted by other miners due to a clash with another block found at roughly the same time. But once accepted, the miner is rewarded with the 12.5 bitcoins and any associated transaction fees. So we'll see what is the proof of work in detail. That is the major task of this proof of work. So this is a proof that enough computational resources, like maybe their memory, CPU, time, everything. So the computational resources have been spent in order to build a valid block, new blocks, like to generate new blocks. Okay. So this proof of work is based on the idea that random node is selected every time to create the new block. The random nodes are selected to create the new blocks. So in this model, node compete with each other in order to be selected in proportion to their computing capacity. So the equation that sums up this proof of work requirement in the Bitcoin, that is the hash of your previous one, that is followed with none's previous hash value of previous block and number of transactions in that block if it is less than the target. So here n is your none's, this is previous hash block, previous hash or previous block hash value. These are the transactions, and target is the network difficulty value for doing the mining. So this means that the hash of the previously mentioned, the hash of your previously mentioned, concatenated field should be less than this target hash value. So the only way to find these nuns is the brute force method. So once a certain pattern of certain number of zeros is met by the miners, the block is immediately broadcasted and accepted by other miners. Accepted by other miners. So, what are the algorithm steps involved to do this mining? Means first is the mining algorithm consists of these steps. The first step is the previous hash block is retrieved from the Bitcoin network. Second, they assemble a set of potential transactions broadcasted by nodes on the network and add them into a block. And once all the transactions are added, then compute the double hash of the block header with a new none value and the previous hash using your SHA-256 algorithm. If the resultant hash is lower than the current the difficulty level or target which we calculated, then stop the process. If the resultant hash is greater than the current difficult target, then repeat this process by incrementing the nuns. By incrementing these nuns. So, as the hash rate of the Bitcoin network increased, hash rate means very frequently generating, suppose, then the total number of 32-bit nuns which are using that will exist. So, the solution for this one is it requires some alternative hashes, extra nuns as required, additional nuns. So, which provides the larger range of your nuns. And then finally, it go for mining the difficulty that increase over time and the Bitcoin that could be mined by a single CPU laptop computers now requires a dedicated mining centers to solve these hash puzzles to follow the brute force method. So these are the steps required in the mining algorithm. So as we said in the blockchain, that the hash rate, when we talk about these hash rates, the hash rate basically represents the rate of calculating hashes per second. So in early days of this Bitcoin, it used to be quite small as CPUs were used, but with dedicated mining pools and the special architectures like ASCP, the application-oriented integrated circuits used for the processors, this has the gone for like your ASIC processors. So this has gone up. This hash rates are gone up exponentially in the last few years. So this has resulted in increasing difficulty. The some of the hash rates are grouped by just checking that the Bitcoin network miners just computing more than some millions of hashes per second now. So the comes to the blockchain replica as said, when any node is trying to join the Bitcoin network, then every pair in the blockchain network maintain a local copy of the block of that blockchain. So it is typically as the Bitcoin, the blockchain technology increase, the size is just about 351 GB of size of copy is there in the blockchain. So as a new user joins this network, blockchain network or Bitcoin network, he or she can get that whole copy. So what is the requirement of that whole copy means? It must be, that whole copy must be, or all the replicas, they need to be up to date, update with the last mined block. So all replicas need to be consistent. So the copies of this blockchain at a different peers need to be exactly the same because it is a distributed network and decentralized network. So because of the property of decentralized one, any peer can hold a copy of your blockchain. So now let us get into some details of your transactions. We talked about the header field of your the blockchain in Bitcoin network. So let us see the transactions in the block of your Bitcoin. So what are the transactions? As we said that the transactions are organized as a Merkle tree. So the Merkle root is used to construct the block hash, as we said, right? So these transactions are the core of your Bitcoin ecosystem, as we said. So transactions, as explained previously in transaction life cycle, let us see the transactions. If a change happens in the transaction, you need to change all the subsequent block hashes. So here to doing that, the difficulty are calculating the or computing the new block names or identity of mining the algorithm that determines the toughness of this tempering with the blockchain in the block. So what are the transaction life cycles means? First, as we discussed, a user or sender sends the transactions using a software called wallet software. We'll talk about this wallet software later. So that wallet software is used to do the signature, or some other interfaces are also used. So once those transactions are signed by this wallet software, then those transactions signed by using private key of your sender. And once they are signed, then those transactions will be, let us assume that transaction 1, your transaction 2, suppose transaction 3. So these transactions will be signed by the software, the wallet software, by using the private key, of your sender. So then you will get a signed transactions, means you will get the digital sign. So that digital sign will be broadcasted in the Bitcoin network. Then the transaction is broadcasted in the Bitcoin network by following some flooding algorithms, network algorithms. So once those transactions are flooded, and if the miners, if they wants to get any rewards, they can act as a miner. So the mining nodes can include these new transactions. Okay, this is suppose sender 1, another sender is there, another sender is adding some transaction 4, transaction 5. So all those transactions will be collected by your miner and add into a single transaction 1, transaction 2, your transaction 3, transaction 4, transaction 5, and try to add in the block. All these transactions will be added in the block. So the mining nodes include these transactions in the next block to be mined. And after adding all those transactions up to date, then the mining starts once a miner who solve this proof of work. That means to calculate the difficult. The difficult means calculating, finding this target hash value. That target hash is greater than the previous hash or not. And then the miner who solved this proof of work problem then broadcast this new block into the Bitcoin network. So that will be received by every node in the network. So then the nodes in the Bitcoin, they try to verify these blocks whether any newer transactions are there added or not, or only the older block is broadcasted again. That will be checked, verified, and once if they find that new transactions are added, then they propagate that block further and they confirms that starts to generate a new block. So finally, once the confirmation once the confirmations start to appear in the receiver's wallet, after the approximately suppose 6 confirmations in the Bitcoin, the transaction is considered as finalized and confirmed, and the new block will be broadcasted. So, however, here we are saying that 6 confirmations is just a recommended number, but the transaction can be considered the final even after the first confirmation. Even after the first confirmation. So the key idea behind waiting for 6 confirmation is that the probability of double spending is virtually eliminated after 6 confirmations. After 6 confirmations. So that is the transaction structure we have seen, and these are some transactions life cycles. So in the transactions, we find the number of transactions which are included. Those transactions will be first hashed with SHA-256. Then again they will be hashed for double hashing, and then those transactions will be broadcasted in the network. So this is one transaction, this is one transaction, these are one transactions. Okay, and after the block, the miner will collect the number of transactions, try to add them into the block. So in the Bitcoin transactions in input and output way, okay, we will discuss this Bitcoin transactions, as we said, in the metadata. The metadata, it gives what is the lack of your time and the part of your transaction that contains some of the values such as your number of inputs, number of outputs, and what are the lock time that which we have just discussed. Okay, we will discuss this in details in the next lecture.